I just now I'm starting. Okay. We want to talk law of cosines now, because the law of sines cannot solve every triangle that we need solved. In particular, you're going to discover law of cosines works better when you have lots of sides in your given information, and you don't know, you only know one angle, or no angle actually. So I'm going to give you the 2-second how they came up with this formula bit. And if you want to see in great detail, there's a page and a half of this proof in your book. Yay.
You mean don't do it?
So this is going to be the quickie version of the proof. That is really not level. Okay, that looks better. I'm going to prove it to you quickly here. What they did is they said, okay, I'm putting this on a coordinate system because you actually have to use the coordinate system to do it. If you have an angle out here, we come over here somewhere. This is my triangle. We're going to call this angle B. Angle, I don't have my other angle. That's got to be, this must be angle A, this must be angle C. Okay. So therefore, where are my sides at? Opposite angle A, this side would be side A. Angle B would be out here, C would be over here. Okay, they want to find, well actually I'll tell you this. You know, if you're given in your problem, you're going to be given side A, you're given angle B, and you're given side C. What geometry theorem does that form? That is side angle side. The most common time when we use law of cosines is when we know side angle side. Okay. In order to, if I wanted to find one part of this so that I could go back to using law of sines, what would be the one part I would need to find so that I could start using law of sines again? Because sines is quicker. I could do.
Find angle C.
But to find angle C, I would have to know a pair. What pair do I know? I don't know any pair. So I could find a pair, though. If I found side B, couldn't I then wouldn't I have a pair with the B's? So what they actually wanted to do is they wanted to find the length of side B. Okay. Back in Algebra 1, you learned how to find how far apart 2 points were.
Distance formula.
The distance formula, yes. So they wanted to find side B by doing distance formula. And so they needed to do coordinates for C and coordinates for A, and then you could do the distance formula. But we can make them.
No, we can't.
Sure we can. These coordinates out here for C are easy. How far over are you to C?
A.
You are A over, and how many up?
Why do we keep using any
0.
Okay.
They always, when we're doing triangles on the plane, they use ABC. That's just the choices. Okay, so coordinates for point C out there, not a problem. It's A over 0 up. Okay, a little trickier. How am I going to give the coordinates of angle A out here?
You can't.
Well, yeah, I can. I need to know how far over and how far up I am.
What else can you do?
You can't do Pythagorean theorem because you don't know 2 sides. Okay, you just last chapter with your polar coordinates learned how to find x and y. X was r cosine theta, and y was r sine theta. This is not going away.
Well, next year.
So they said, oh, if r is my distance from the origin out to that point. So in this case, what is this length r here? It's C. So r is just nothing more than side C. So you're doing C cosine of whatever angle. It's actually, this is the reference angle. We're actually doing angle B. This would just be its reference angle. So you can just do C times the cosine of B, which makes this one then C times the sine of B. So you actually get, I know this is horrible looking coordinates, but you get coordinates of C cosine B and C sine B. Okay, now here's where we aren't going to do all the algebra. But they now have these coordinates. They do distance formula. Anybody remember the distance formula? Oh, yeah. In a big old square root. So if you imagine taking all these coordinates, subtracting the x-coordinates and squaring them. You're going to have c cosine b minus a, that's your x-coordinate squared. Your y-coordinates are c sine of b minus 0 squared. I didn't write very well there. Okay, if you actually square those out, you're going to get a sine squared plus cosine squared in there that equals 1. If you actually do all the algebra on it, we would actually be finding how long side b is. It turns out if you do the algebra to simplify this mess, they don't like the square root. So they get rid of the square root by doing what?
Why do you do square?
Yeah, so they write the formula b squared because they don't want the square root in it. And it actually turns out when you do the algebra to simplify that out, you're going to end up with a squared plus c squared minus 2b, oops, 2ac, sorry, changing letters, cosine of b. When you actually, because when you FOIL this, you'll get, when you FOIL it all and you combine terms, you'll end up with that lovely mess, which actually isn't as hard to remember as it looks. You'll notice if you are solving for side b, what letters are all over here? The sides are always a's and c's. So it's a squared plus c squared minus 2 times those same two sides, a and c. Now, how does the angle relate to what you're solving for?
The sine.
Yeah. If you're solving for side b, you'll have angle b in your formula.
Yeah, but
Okay. Now,
squared.
then you'll have to square root the answer when you get it worked out to get the side b. Now, they actually write this in all three forms. You're going to discover you actually really don't even have to be able to recite this formula by letters because you'll learn what to fill in where automatically. But if I was said change this formula to solve for side A, what would change? Okay, b squared and c squared has to be the other two sides. Minus 2bc of angle A because we're solving for side A. On the very last question on the first page of your journal says, write all three versions of the law of cosines.
Should I?
Could you write down A, right, with the law of sines and with the geometry theorem?
Yeah, over there on the board. So law of cosines here. You all just told me what geometry theorem did I give you there? Right here, what'd you have?
Side and side.
You had side angle side. So law of cosines works for side angle side, and it works for one other one.
Hypotenuse leg.
Hypotenuse leg
Side.
is really, you know, the right angle. So it's really, it's a, it's actually side angle, but it works because it's 93, it only works because it's 93 angle. There's another one, what did you say? Side, yes. So law of cosines works if you know all three sides. Yeah, these are the actual. That's the three different versions of the law of cosines. But like I said, as soon as you work a couple problems, you don't even have to really know the formula because you're just going to follow what numbers to fill in where. It just makes sense. But that is your law of cosines. Are we ready? Can I switch?
Is that on the b square root of plotting that in there? What's that after the b minus?
Sorry, that was 0.
Okay.
B sine B. And it's not horrible algebra. It would take 3, 4, 5 steps if you really want to see all the algebra in your book. But you end up with sine squared plus cosine squared equals 1 in there, and it works out pretty sweet, actually. All right, so let us try one here.
What is the geometry theorems in which you can use? What's the maximum number of times?
We just wrote them.
No, it says write all three versions of law of cosines and the law of cosines.
And the geometry theorems that you can use.
Oh.
Side angle side and side side.
That's the law of sine. Hey,
Yeah.
how many times can you use the law of cosines in one problem?
You'll see here in a moment as soon as we work one.
That's 3. 1.
Yeah, it's it. Alright, here we go. Once again, not drawing the scale here. This is 5.8. The angle is 35 degrees, and we have a side of 3.7. And so you look at it and you go, oh look, it's side angle side. Yeah.
All of the geometry theorems, you want to try all of them?
I want you to write the ones that apply to law of cosines, which there are two.
So just side angle side.
And side, 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 because the others don't work with law of cosines.
Is there one for angle, angle?
Angle, angle, angle was a similarity theorem, it was not a congruence theorem. So no, that is not true, because angle, angle, angle just means the triangles will be in proportion. It doesn't guarantee they are equal size, so it does not apply in this situation. Alright, so since you see you've got side angle side, you go, oh, I have to use the law of cosines. Okay, since the law of cosines, the formula has how many sides in it? You have to know two sides, and you have to be finding the third. So, therefore, as we know two angles, and we have to, we have to know two sides, we have to know the angle in between them, and it forces you to find the third side. You have no choice here. So, regardless of, once again, whatever I may say, I may tell you to find the angle B, but you can't go find angle B right away, because law of cosines won't do that for you. You have to find what first? You'd have to find side C. So you're starting out with side C squared. Don't forget your square. And then, okay, the formula says take the other two sides. I should write that here. So you're automatically going to take the other two sides that you've already got, which are B and C. So you're already going to use the 5.8 squared and the 3.7. You automatically have to use those two sides. It doesn't matter which one in which order.
And it doesn't matter that one's a side and one's an angle?
Well,
Oh wait, never mind, sorry.
okay. And then you're going to go minus 2 times those same two sides. You use those same numbers. So you're just going to fill them in. And then lastly, it has to be cosine of what angle? See, it's the only angle we got. Cosine 35. Now the beauty of this is actually set up correct with order of operations. You can plug that whole thing into your calculator as one big long list. It'll do it correctly because it's going to do order of operations right. What you have to remember though is once you put that in the calculator, you have solved for C squared. So if you run that whole thing in your calculator, you'll get something like about 12.17. Is that your answer? You have to square root your answer every time then after you get it out of the formula.
So can we just put that all in the square root?
You could, yep.
Yeah, this is at 3.5.
That comes out about 3.5. Okay, so you got 3.5. Now, have you answered the question?
No. Find B.
The question was find B. So do you have to do law of cosines to go find angle B? Now that you have figured out this side is 3.5, now you can always go back to using law of sines. Once you find that one missing part, you can always go back to law of sines. So you only ever have to do law of cosines once.
Well, how would you use the side angle?
Because now I have a pair,
I get it.
so now I can do law of sines to find anything else once I've got a pair.
So you must have to find,
Okay, that part I've got to what you have to find next.
Is it a side angle? We get check for the double.
Okay, well first of all, side angle, this can't be. You started with side angle side, so it can't be side angle ever. You will have to, this cannot have two triangles. It can't happen. You will have one answer. The only time you could have two answers on side angle, on log cosines, you will never have two possibilities. But I do have a wrinkle for you. It's kind of rare. Doesn't happen real often, but I just probably do the very thing I want. So we're going to look at something here a second. It says find angle B. How would you guys find angle B?
find a B over 5.8.
Yeah. Okay, we,
Like 1 second.
oh, yikes, thanks, we'll go back, we'll stop.